Hello, class. It's nice meeting you once again. You'll recall the last time we met, we talked about ionic compounds and ionic bonding. Ionic bonding is formed by electron transfer from metals to non-metals. Okay, and their bonds are said to be strong and have high melting and boiling point. But today we'll be looking at another type of bonding, which is the molecular bond. Uh, the molecular compounds generally form what we call covalent bonding. And covalent bonding is formed by the sharing of electrons. Okay. Remember, atoms bond to achieve stability. Okay, to achieve the noble gas configuration. So, and when these covalent bonds form, they form what we call molecules. Okay, ionic bonds form what we call ionic compounds, while covalent bonds form molecules. Okay, and they have just one objective, and this objective is to achieve stability. So the first example I'm going to share with us is using the fluorine atom. The fluorine atom has 9 electrons. Okay, and if you are to distribute these electrons based on energy level, first energy level will take 2, and the next energy level will take 7. So fluorine has 7 outer electrons. So we'll be focusing on the outer electrons only for illustrative purpose, okay? So I'm going to place 1 here, and then 2 electrons here, 2 electrons here, and then remaining 2 electrons here, making 7. Now you would notice the fluorine atom has 7 outer electrons, which means it needs 1 to achieve that octet structure to make the outer electrons to be 8 for stability. Now, the next fluorine atom too is also in need of 1. So they can come together like this and share each of the electrons they have. Okay. They do so. So this also have 7. I'm using another symbol so that we know these are the atoms of the other fluorine. Okay, now if you're to count what each has, you've achieved stability. Okay, 1, 2. So this will be 1, 2, 3, 4, 5, 6, 7, 8. If you're to continue the counting for the other chlorine, you should say 1, 2, 3, 4, 5, 6, 7, 8. So that way they achieve stability by sharing electrons together. Okay. If you look at the notes here, the example shared here is that of the chlorine atoms. Chlorine too has 7 outer electrons. As you can see, the blue electrons we have here, 7. And the pink balls here also are 7. So for them to achieve stability, okay, or a full outer shell, they have to come together. Okay. So you can see when they share these electrons together, they form what we call covalent bond, and that results to a stable chlorine molecules. This explains why chlorine molecule are diatomic. You can see chlorine existing as just Cl. It has to exist as Cl2 for stability. Okay. Same thing applies to nitrogen. I would like to share another example with nitrogen. Nitrogen has 7 electrons. Okay, and that means it's going to have 5 outer shell electrons. Okay, and then it has 5 outer shells. It simply means it's in need of how many? 3 to achieve stability. Okay, so we'll place 3 here to be shared by another nitrogen atom. and the remaining 2 electrons, we'll put them here. Okay, we'll bring another nitrogen, which will bond with it, with also 3 on the same side, because it's also in need of the 3, this other nitrogen. So with this, they've achieved stability, but not just one, because this is just 1 electron shared each. So if I'm to write the bonding for this, I will just use a line. 1 bond, 1 covalent bond is existing here. But for nitrogen, what was shared for each atom is 3 each. So there's a bond between this and this, there's a bond between this and this, and there's another bond between this and this. So that makes nitrogen molecule to have a triple bond, 1, 2, 3, because they shared 3 electrons each among themselves. Okay, and that gives rise to the nitrogen molecules. Okay, now the properties of molecular compounds is such that they have low melting and boiling point. The reason is because the intermolecular forces between them are very weak. Okay, not the covalent bond. The intermolecular forces that hold these molecules together are very weak. Hence, they can easily give way, even at very low temperatures. Okay. This is a point we would like to drop and stop. Okay. Thank you for watching, and remember to click on the subscribe button. Till we meet again. Bye.